Our project is AI Use in Intrusion Prevention and Detection Systems, IPS and IDS. So we'll be going over an introduction to IPS and IDS. We'll be explaining what AI brings to these components of network security. We'll explain how AI and IDS work. It only works in IDS at the moment because it's used to detect threats using data sets it was trained on. We'll be explaining what problems AI-powered IDS solve, and we'll explain what issues this also raises, as well as the future of AI use in IPS. And at the end, we'll wrap up with some thought-provoking questions. So let's begin.
An intrusion detection system, an IDS, and an intrusion prevention system, an IPS, are fundamental components of network security. An IDS is more of an alerting system that lets an organization know if malicious activity is detected. An IDS monitors and detects behavior across a network and should only be considered a diagnostic solution. An IPS, intrusion prevention system, has the same functionality as an IDS, an intrusion detection system, in terms of detection, but it also contains response capabilities, which makes it a system that has more agency. It takes this detection in an IDS a step forward and shuts down the network before access can be gained or to prevent further movement into a network. The response is the most important difference between these two systems. An IDS will stop at the detection phase, leaving one to freely decide what action to take. In contrast, an IPS will take action to try and contain the threat and prevent further movement into the network.
What is cool about AI use in IDS? There are four primary benefits of AI use in IDS. These consist of automation, adaptability, better detection accuracy, and improved efficiency of analyzing traffic. Automation allows AI to act as a security analyst so it can detect threats more accurately than a human. While this could reduce the need for human security analysts, it primarily just makes their job easier as human oversight will always be needed for network security. When it comes to adaptability, that is dependent on the training of the machine learning models as they can improve with new threats being added to the data sets over time. For detection accuracy, the machine learning models are trained to categorize abnormal behavior with high accuracy and improved precision. But this is all dependent on the quality and quantity of the data sets it was trained on. Lastly, for efficiency, this is dependent on the hardware specs so they can run the machine learning model on large volumes of traffic consistently.
IPS systems monitor networks, traffic, and activity across devices and servers. The monitoring and learning functionalities go hand in hand. AI-based security algorithms are implemented to identify malicious behavior patterns that humans otherwise would not be able to detect as thoroughly due to the huge volumes of network traffic. The drawback in this is that this technology can only identify the behavioral patterns that the algorithms have been trained to identify. The IPS can identify malicious traffic only if a signature matching that specific malicious traffic has been installed. No signature means no detection. This means the IPS cannot detect attacks whose signatures have yet to be developed. However, the ability of AI, and machine learning in particular, to make decisions based upon data rather than the set rules and algorithms promises to yield significant improvements in detection. To address the issue of limited detection in terms of what type of traffic can be detected, IPSs have employed heuristic anomaly detection. To further explain this, it is important to note that IPS technologies have access to packets where they are deployed. Through comparing packet flows to either a predefined signature or anomaly-based detection method, the system looks for behavior that is out of the ordinary, as well as classify traffic as either benign, suspicious, or unknown. The suspicious or unknown traffic is flagged, the systems generate an alert, and then finally a human operator determines whether the threat is malicious. The drawback in this is that the large volumes of data analyzed by IPSs typically entails a great number of alerts generated, but also a large amount of false positives.
Now let's delve into the significant problems that AI-powered intrusion detection systems solves. First up, false positives. These are false alarms or alerts that traditional systems generate, which can overwhelm security teams and lead to missed real threats. AI algorithms are adept at reducing false positives. They do this by learning from vast amounts of historical data, allowing them to distinguish between genuine threats and harmless network activity. Next, behavioral analysis is a critical component of modern IPS and IDS. It involves continuously monitoring network traffic patterns to identify anomalies, a task that's challenging for humans alone. AI plays a crucial role here by conducting automated behavioral analysis. It can spot deviations from normal network behavior, which can indicate an intrusion attempt or a compromised device. Lastly, let's talk about advanced threat detection. Traditional IDS systems often struggle to keep up with the evolving nature of cyber threats. This is where AI comes into play. AI enhances our threat detection capabilities by analyzing massive amounts of network data in real time. It can identify complex and evolving threats, even those that have never been seen before, like zero-day attacks.
AI-based intrusion detection systems could raise some issues. It can sometimes generate false positives or false negatives, and false alerts can lead to unnecessary disruption and ruin the workflow of the organization. Attackers can attempt to manipulate AI-based IDS systems by formulating attacks specifically designed to evade detection. Attacks can exploit vulnerabilities in the AI models, leading to security breaches. AI and IDS systems involve the analysis of network traffic, which includes sensitive data. This raises the question of the ethicality of that data to be handled freely by artificial intelligence. Security professionals may not fully understand how these new systems work, making it challenging to manage these systems effectively. Security professionals need to understand when to trust AI recommendations and when there is a cause for human intervention. Implementing AI in security systems demands significant computational resources and infrastructure. This can strain budgets, particularly for smaller organizations, and scalability can become a concern. Maintenance and regular updates also contribute to resource intensiveness. AI algorithms can introduce bias in threat detection due to their learning from historical data. Ensuring fairness, accountability, and transparency in these models is crucial for unbiased results. It's essential to address and rectify any biases that may arise during AI implementation. Currently, many IPSs and IDSs employ artificial intelligence methods in their systems, and the use is expected to grow in the near future. We expect AI techniques will improve understanding of how non-intrusive and intrusive behaviors differ, as well as enable classification of different types of attacks through these systems. Since more and more organizations are converting to a cloud-based environment, AI-powered IPS and IDS solutions will adapt to protect these environments and will provide tougher security methods to them. AI-driven IPS and IDS systems will also become more capable of making real-time decisions and initiating automated responses to threats as the AI becomes more efficient. Machine learning algorithms will continually learn from new data and adapt to emerging attack techniques, making them more resilient to various malware attacks, and in turn will make our overall systems more secure. The future of AI and IPS and IDS is expected to bring about more advanced, proactive, and adaptive security solutions that can effectively counter evolving cyber threats in an increasingly digital world.
These are some thought-provoking questions. In the context of AI-driven IDS, what ethical guidelines should be followed in order to ensure that these guidelines are implemented to protect both security and privacy? How does AI-driven IDS adapt to increasing complexity of cyber attacks while maintaining their effectiveness in threat detection? And lastly, today AI is primarily being used in intrusion detection systems, since AI is great at identifying threats. But how can AI improve intrusion prevention systems? And here at the last slide, we have some references.